We've seen in the last couple of videos that there's a relationship going on between sample size and error and sample size and confidence level. There's a whole bunch of stuff going on. So now let's flip it around and ask, how would changing your sample size affect your confidence interval? So I have an example here where we have 4 out of 10, right? 4 being your x, 10 being your n. And I want us to determine our p hat and then find a 95% confidence interval, right? Okay, so this isn't going to be that hard because we're just going to make the calculator do it all over, right? See, it says use your calculator. So we're going to use the calculator. So let me go to the calculator, clear this out. Stat, tests. I want letter A, which is one prop z int. So you can actually just hit alpha A and then it'll happen real fast. So you have 4 and you have 10 and we want a 95% confidence level. Then we press calculate. And here's our result, 0.09636 and 0.70364. And you'll notice, this shouldn't be any shock, your p hat is 0.4 because that's 4 out of 10. So let me go type all that into that table. Okay, so here's the p hat, which is 4 out of 10, which is 0.4. Then I found this interval to be 0.09636 and so on. And then just a little reminder that your margin of error is half your width, right? So that means that you're going to need to take the width, which is the high number minus the low number, and then divide it in 2. So let me grab the calculator. And I need to take half that width. So I need 0.70364 minus 0.09636. Find that value, divide it in 2. Or you could do it all at once with parentheses. It's fine. So you get 0.30364. All right then. So now we're going to do it again, but we're going to change our numbers to 40 and 100. So I go to stat, tests, pick number 5. Oh, letter A. Sorry. We're doing letter A. So alpha A. But now I want 40 and 100. I'm still leaving it at 0.95 for my confidence level, and I go down to calculate. And that gets me 0.30398 and 0.49602. Okay, so I filled in, it's still 40%, so 0.4. Then this is now my interval right here. And I mean, just look at it. This one was 0.096 to 7.70, so quite a huge interval for a population proportion, excuse me. And this is only 0.304 roughly to 0.496. So we need to find that margin of error. I'm going to do it all at once this time. I don't feel like doing two separate parts. So parentheses 0.49602 minus 0.30398, close my parentheses, divided by 2, and it's 0.09602. 0.09602. So we went from having a 30% error, look at that, 0.30, 30%, to a 9.6%. That is quite a significant difference. All right, now let's do it again. 40 out of 400, excuse me, out of 1,000. So same idea. I go back to stat, move to tests. Alpha A is the one I want. That's the one prop z int. I'm going to do 400 out of 1,000. Still leave it at 95% and calculate. And look there, 0.36964 and 0.43036. So let me write those up right here in the notes. All right, so I have 400 out of 1,000. That was, this right here is the confidence interval that came out of the calculator. And then you need to take the high number minus the low number and cut it in half in order to find your width, which, let's see, would be parentheses 0.43036 minus 0.36964, close parentheses, divided by 2, and I get 0.0306, which shouldn't be any shock because you see the 3036 added on to this. And there we have it. So now look what's happening to our error. right? Now, what happened? What changed? Our confidence level didn't change, but as we moved our way down the table, it was getting smaller and smaller for our error. Now, why did it happen? Why are these errors getting so much smaller? We started at 30% for our error, 0.30, and we end up at 3%. And the answer to that is what's happening here, right? So changing our sample size. We didn't change our proportions though. I mean, we changed our x's accordingly to match our sample size. So, but changing our n, increasing it, what happened to the confidence interval itself? Well, the intervals are shrinking, right? They're shrinking in size. And you can tell that because the error is half the width of the interval. So what's happening is your error is getting smaller, which means your interval is getting smaller. These numbers here at the front, these are really far apart, right? 70% and 9.6% are really far apart. Whereas these ones down here, 36.9% and 43%, are not that far apart. Okay, so I tried to type this up. Increasing your sample size n causes the size, which is the same thing as width and size are the same, of your interval, confidence interval to decrease, right, to go down, right? So increasing n will cause the size to decrease. And that's what they asked us for. Now, why is that? Well, it's because the size slash width of the interval is actually 2 times the, actually, I'll make that an equation, 1 second. There, the size, i.e. the width, is equal to 2 times the margin of error. And we already know that the error and the n are inversely related. So the same is true for the width. And I'm writing both size and width. That's why the slash, because size and width get used kind of interchangeably. Width means how wide the interval is. That's the exact same thing as the size of the interval. All right, so we've now learned that size and width of an interval and the sample size are inversely related, just like the error and the sample size are inversely related. Matter of fact, it's because the error and the sample size are inversely related.